All right, welcome to Monday, February 13th notes. You should have your note packet in your folder. Turn to finding area of a rectangle, which is going to look like this. This is what we're going to be doing today. So make sure you get turned to this. This will be your video for notes. You will have a somewhat short homework assignment with it, or hopefully you'll be able to get it done in class. I have over on the sideboard, over towards the wall, towards the hallway, put all the formulas that should be on the front page. And let me get there for you. On the front page, all the formulas should be over there on the front wall. Hopefully you're starting to learn them as we use them more and more. You should be able to start picking them up or understanding them. The answer key for this will be online, as always. Hopefully you did okay on your complex figures, or at least gave it a shot. You know, a little bit of effort is never going to kill you. So hopefully you did well on that for those who really did try. All right, so let's get started. We are going to find area, and we're going to do it by shearing the polygons that we're looking for. So we could have a square, a trapezoid, a triangle. We're going to learn how to shear. It's a pretty easy method once you pick it up. It's not too bad. One of the great things is when we have polygons on a coordinate graph, meaning where they're on a graph that you've seen, that you can find the distance of these really easy just by counting. We're going to use that concept today. All right, so let's get started. We're going to start with two rectangles. We want to calculate their areas using whatever technique you want. I'm going to start just by counting so you can see how it's easy to do. We have nice two rectangles. When I look at this, I see I'm going to count, and you're going to see me label these because it's going to help. I'm doing it for you. I could do this without it, but hopefully this is going to help you. So I look at this, I want to see the width. Well, from point to point, this is 1, 2, 3 spaces. From point to point, I've got 1, 2, 3, 4, 5, 6. So I look at this, this rectangle is 3 wide by 6 length, right? 3 by 6. So wouldn't that be area 3 times 6, or 18? Now, since we are on a coordinate graph, we're going to use units squared. So units squared. And here soon I'll just abbreviate to U, but I need you to see that. Since we are on a graph, these are units. 1 unit, okay, so from 1 to 2 is a unit. These are units squared. Looking at B, I'll do this in a different color. It looks like I've got a square, but not positive. Let me put this in full screen. Okay? Not positive, but let's count. Well, I've got 1, 2, 3, 4, 5 down. 1, 2, 3, 4, 5 across. Sure enough, I've got a square here. How do I know that? Because it's a 5 by 5. Everything's going to be the same, which makes it a square. So 5 times 5 is 25 units squared. Told you I would just go ahead and abbreviate to U, so this is units squared. All right. So now let's take a rectangle that isn't perfectly like on a horizontal and a vertical axis, one that's turned slightly. What are we going to do to find this? Well, I can do the same idea here. I can still have the same idea. I'm going to slide this over just a little bit as you see me turn the screen just a tiny bit. Hopefully you get over here, yep. So as I look at this, here's what I'm going to do. I want to box this or rectangle this in. So I'm going to go from my outer point, my top point. I'm going to rectangle it in. The outer point, the outer, and the outer. What I have done is I've enclosed my rectangle. Well, I've enclosed it with the shape. So like on our complex figures, when we had the shaded, and we had to take out the unshaded circles, the half circles, this is kind of like what we're going to do there, okay? So as I look at this, I want to count down. I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, and 7. So I know that the area of the whole thing is going to be 5 times 7, or 35 units squared. Now, I don't want the whole thing, I just want the inner half. Well, notice when I do this, we created right triangles. That's the key here. We've created right triangles. I've created a right triangle up here, and I'm going to shade it in green. So I've got a right triangle up here, and then I've got a right triangle down here. You're going to see it. And then I have a right triangle here and a right triangle here. And so you notice that I got 4 of them in there. Well, hopefully you're going to see the pattern with it real quick, and you're going to notice that they're going to be the same. But let's figure it out. So I want to find the area of the blue. Now notice I'm using blue to go along with my blue. Well, let's count it. 1, 2, 3, 4, 5, 6. So what's the formula for a triangle? 1/2 times base times height, right? So my base is 6, my height, 1, 2, 3, times 3. So 1/2 times 6 times 3, well 6 times 3 is 18, times 1/2 is 9. So this is 9 units squared. And let's do the green one. Up 1, 2, 3, 1, 2, 3, 4, 5, 6. It's exactly the same, so I'm just going to write it. If you notice that it's the same, just write it. You don't have to do the math more than once. Okay? So now let's do the 2 blacks. Down 1, 2, over 1. Down 1, over 1, down 1, 2. It's exactly the same. So the area of the right triangles is 1/2 times 1 by 2. And since there's 2 of them, I'm just going to go ahead and multiply it by 2. Notice this last 2 is not in the formula of an area of a triangle. Since I have 2 triangles, it's exactly the same. I'm going to multiply by 2. Okay? So I have 1/2 times 1 times 2 times 2. Well, 2 times 2 is 4, times 1 is still 4, times 1/2 is 2. So 2 units squared. Well, what is all of it? Well, all of it is going to be 35 minus 9 minus 9 minus 2. Well, what is 35 minus 9 minus 9 minus 2? 35 minus 9 minus 9 minus 2 is 15. So my units is 15 units squared. My area of my rectangle, my original rectangle, is 15 units squared. All right. Hope everybody can see that. Let's move on because we got a couple. We got a few more. Reminder that if I go too fast for you, please pause, rewind, come back. Okay? We're about 8 minutes in. This is going to be about 25 minutes. All right? So you have time to pause. You have time to rewind. You have all that time. Okay? All right. This one says, draw a rectangle with the same height and base as the parallelogram. We got a parallelogram this time. And then use shading to demonstrate how the area of the parallelogram is equal to the area of the rectangle. Use shading to demonstrate how the area of the parallelogram is equal to the area of the rectangle. So here we go. I'm going to draw it. Do exactly what it just asked me to do. I'm going to label it 1, 2, and 3. 1, 2, 3, 4, 5, 6. So I know that the area of the whole thing that I just did is, area is 6 times 3, or 18 units squared. Now, notice that when I did this, I created 2 triangles. Once again, they're right triangles. I've got this one here, which I'm going to shade in red. And this one right here, and I'll shade in green. I use blue on my notes. So when you look at it online, it'll be in blue, but it's right there. Okay? So those are my two triangles that I created by putting the box around my parallelogram. Now, I found the area of the whole thing. If I find the area of this, the red part, and the area of the green, and I subtract it from the whole thing, it will give me the area of the original parallelogram, and that's what I'm going to do. So, area of red, okay, area of red is 1/2 times base times height. Well, what's the base? Well, let's see. What do we got there? We have 3, right? 1, 2, and 1. Right? Oh, did you notice I made a mistake? Hopefully you did. I went too far. I went too far. I thought that looked weird. I should have just gone straight up. Hopefully someone caught this before I got too far and you're like, Mr. Mosier, stop, wait, wait. Okay, so notice that I made a mistake. I actually am glad that I did because you can see, because when I went to do that, I couldn't get a triangle out of it. It wasn't a triangle anymore. So I knew I made a mistake. Okay, so this is a good learning opportunity. If you make a mistake and you get to something, you go, wait, I can't do anything here. You might have just made a simple human error. Okay? So now I'm going to do this in red like I had it originally. And I look at this, and I go up by 3, but only a base of 1. So 1/2 times 3 by 1. Well, 3 times 1 is 1. Times 1/2. What's half of 3? 1.5. So I know this is 1.5 units squared. Well, let's look at the area of the green triangle. And you notice that I'm doing this all in the color that I'm choosing so you can see the differences. I still got the area of a triangle, so it's 1/2. You should be getting good at this formula. 1/2 times base times height at this point. Base is 1, height is 3. Notice that it's the exact same values. Notice it's the exact same values. So I know my overall area of the parallelogram is going to be 18 minus 1.5 minus 1.5. Well, really, that's 18 minus 3, right? So that becomes 15 units squared. So that is my area. All right. Moving on. B, same idea. Same idea. I'm going to draw it this time, hopefully not make the mistake that I made. Come straight down, come over, come straight up, go over. Once again, I created 2 right triangles. This time I know I created 2 right triangles in a good spot. I'm going to do red and blue this time. Red and blue. Here we go. Label it. Well, I only went up 1. 1, 2, 3, 4, 5, and 6. So I know the area of the whole thing is 1 by 6 or 6 units squared. Looking at my area of the right triangle that I created, up 1 over 2. So area is 1/2 times 1 times 2 or 1 unit squared. And of B, or the blue, over 1, 2, up 1. Well, it's the same thing. 1/2 times 1 times 2, or 1 unit squared. So my whole thing is 6 units squared, but my inside, which I'm going to do green right now just so you can see, the inside of my original parallelogram is area equals 6 minus 1, which is 4 units squared. So my answer is 4 units squared. All right. C, I'm going to let you do on your own. Hopefully, you get to, and I'm going to write it for you, 6 units squared. I want you to work this one on your own. You should be able to get to 6 units squared. Okay? If you can't, refer to my notes. I'm going to put them online. I'm going to put my copy of my notes. You can see my work down here. but you need to try to be able to do this. All right? So we're going to move on. So 6 units squared for that one. Let's do the next one. Area of a triangle by shearing. We can still do this. We can still do this. Okay? Now, do I know parts of this already? Well, I do, don't I? I could go here, here. I could really do this without shearing. Okay? I really could. And let me show you. Okay? I'm up to my height. My base is 1, 2, 3, 4, 5. So 1/2 times 2 by 5. Well, it should be 5, right? Because 5 times 2 is 10. Take it by half is 5. So I should get the answer 5. But the reason I'm going to show you this is it's not always going to be this nice and neat, okay? It won't be where 2 of them aren't exactly on a vertical or horizontal axis, and it's going to be difficult. So what I want to do is go ahead and do what I've been doing, and that is connect my outside, draw my thing. Well, this time I've only created one right triangle. Well, it looks exactly like the one I originally have. I wonder if it's the exact same. Okay? Well, let's find the area. I'm up 1, down 2, right? 1, 2, 3, 4, and 5. So the area is going to be 2 times 5, or 10 units squared. Now remember, I keep saying that it's going to be 5 units squared. I'm going to go ahead and write it over here. I want you to see that we're going to prove it. Okay? Now, I need to find the area of the red area where I just shaded. So area of the red triangle, well, it's still up 1, 2, and it's still over 5, right? But the area of a triangle is 1/2 times 5 times 2, right? So 10 times 1/2 is 5 units squared. Well, since I found the area of the whole thing after I filled it in and found the area of what I created, I should be able to subtract all of it from what I created to give me the original. Well, once again, let's look at it. Area equals 10 minus 5. That should be 5. Well, is that the answer we originally came up with? Yes. So, since this was nice and neat, you could have just used the formula, right? But they're not always going to be nice and neat, so you know how to box it in and make a rectangle. Okay? All right. Area of a hole. All right. We got some more, right? So here we go. This one's not as nice and neat, just like we talked about. So we're going to go ahead and have to create my rectangle all the way across, down, and there we go. So I created this rectangle in here. I'm shading with red. I created this one. I'll shade it in green. So I've created 2 triangles inside my rectangle, with the third is what I'm looking for. So let's find the area of the whole thing. Well, 1, 2, 3, down, 1, 2, 3, 4, 5, 6, 7 across. So area of the whole parallelogram / rectangle is 3 times 7, or 21 units squared. All right. Let's find the area of our red shaded triangle. So area of our red shaded triangle, it is a right triangle as always. I'm up 3, my height is 3, my base is 2, 1, 2. So 1/2 times 3 times 2, that is 6 times 1/2, or just 3 units squared. Now notice, if you need the calculator out and you can't see that 3 times 2 is 6 times half is 3, put it in the calculator, please. All right, let's find the area of the green shaded triangle. Up 1, 2, 3, over 1, 2, 3, 4, 5. That's over 1, 2, 3, 4, 5. Notice that. Okay? 1, 2, 3. So this is 1/2 times 3 times 5. Well, 1/2 times 3 times 5. Well, 3 times 5 is 15 times 1/2. Well, 7.5. Once again, if you can't see that, put it into a calculator. So let's find the area of my original shaded or my original triangle, which is going to be area equals 21 minus 3 minus 7.5, which should equal, well, that's 21 minus 10 and a half. Well, 21 minus 10 and a half is 10 and a half. So my answer is going to be 10.5 units squared. All right. Once again, I'm going to let you do this one, okay? I've done 2. You can do the 3rd, okay? I'm going to tell you that you're going to have to find this right here, right? And you want to find this right here, okay? Find those, get your answer. Check mine forward, okay? All right. Labeling. Label the 2 bases, B1 and B2, and then draw in and label the height of the trapezoid. We got to be able to do this, okay? You got to be able to do this. So, I'm going to label the top B1, the bottom B2, and then my height from the top straight down to the bottom. So, straight down to the bottom. That is my height. Remember, the formula for this is area equals 1/2 times base 1 plus base 2 added together before you multiply times the height. Okay? The second part, label 2 bases, B1 and B2, draw in and label the height, and label the legs of the, ooh, big word here, big word, isosceles trapezoid. What does isosceles mean? It means that the 2 legs are equal. They're equal. They're the same, right? So here we go. Label the 2 bases. Well, B1, B2. Draw in the height. There you go. Did it matter if I use this one or this one? It doesn't. They're the same, right? Because it's parallel. It's flat, right? It's going horizontal this way. So it doesn't matter if I use this point or this point. It's going straight down. They are the same. All right. So last one. This is the last one on the notes. You just had 2 of them that you had to do yourselves before moving on to the homework. We're at 22 minutes right now. We'll be done here in just about 2 minutes. All right, it says create a rectangle around the trapezoid. What is the area of that rectangle? Remove the triangle to create the trapezoid. What is the area of the trapezoid? So let's do that. Make a rectangle around the trap. Up. Done. Good. We made a rectangle. Let's count it out. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So I know the area of the rectangle is 3 by 7 or 21 units squared. Now, it said, what is the area of that rectangle? Well, we've done that. Remove the triangle to create the trapezoid. Well, the triangle is right here, right? My red shaded area. Well, the area of that is 1/2 base times height. So 1/2 times the base times the height. Well, 3 by 1, 2, 3, 4. 1, 2, 3, 4, 5. So 1/2 times 5 times 3. Well, that's going to be 7.5 units, right? So what is the area of the triangle? Well, triangle is 7.5, right? So what is the area of the trapezoid? Well, the area of the trapezoid is the rectangle minus the triangle. So area equals 21 minus 7.5, which is going to be equal to what? Well, let's do that. 21 minus 7.5, and that is 13.5. Well, 13.5 units squared. That is my area of the trapezoid. Okay? So we have found it. Now, once again, I kind of talked about this earlier in one of the examples when I had a triangle on a nice, even vertical and horizontal plane. This one has the same idea. What are the dimensions of the trapezoid? Well, my base 1 is what? 1, 2. So base is 2 plus 1, 2, 3, 4, 5, 6, 7. 7, right? What is my height? 1, 2, 3, my height. Well, let's put it in. Area equals 1/2 times 2 plus 7 is 9 times 3. Put that in your calculator. See what you get. 0.5 times 9 times 3. Well, 13.5. Notice, when they are on nice, even vertical and horizontal planes here, we can just use the formula. That's one of the great things of being on the coordinate plane is we can just simply count at times, okay? When they're off-centered, we've got to be able to do the shearing part, and that is create a rectangle around it, find the hole, subtract what you created. That gives you what you need, okay? But outside of that, if they're nice and neat, just count. All right. This has been your notes. We're at 26 minutes even right now. Have a great Monday. See you on Tuesday.